Hello everyone, and welcome to another webinar for technology investors from ARM. Today we're going to be talking about low power wide area radio, which is an important communications technology that's going to drive the next wave of IoT adoption. I'm joined here by my colleague Chet Babla, VP Solutions IoT Devices, and Sandeep Deshpande, Head of European Technology Research, JP Morgan. So in a moment, Chet is going to run through a few slides explaining what low power wide area networking technology is, where it's used, and before he does that, let's hear quickly from Sandeep. So Sandeep, could you tell
Thanks. Sorry.
That's all right. I was going to say, Sandeep, could you tell us why low power wide area radio is now becoming a talking point for investors?
Thanks, Phil, for doing this webinar with us. I mean, in terms of the market itself, telecom operators and telecom equipment companies have been telling us for the past year or more, in fact, that they will see new revenue opportunities arising from IoT. What investors in semiconductors understand is the opportunities associated with local networks, such as with Bluetooth, Wi-Fi, which create personal area networks. But what they don't understand in terms of technologies and protocols is what are these technologies and protocols which will enable IoT based on wide area technologies such as LTE and 5G. And thus, we find it very useful that if ARM could talk to us about these technologies and the technologies that will enable this IoT market and the protocols that will enable this market. So thanks for joining us on this, and I will hand over to Chet Babla, VP of IoT Solutions at ARM, to talk about these protocols and technologies. Thanks, Chet.
Good afternoon. Thank you, Sandeep. So just to give a quick introduction to myself, I'm heading up the IoT Solutions team here at ARM, and our kind of primary remit here really is to help ARM to define IoT device strategy, and we're doing this by ensuring we engage with the whole ecosystem here. So this is carriers, this is the cloud players, this is standards bodies, this is regulators, software vendors. IoT is a hugely complex area, so it's very critical that we do work with all of the ecosystem partners. I have 25 years of experience in the industry. Hopefully the photograph doesn't show that. And my previous roles have been including MediaTek, CSR, worked at several semiconductor startups, and I've had the opportunity to work with the UK government in terms of international trade. Okay, so to get to our topic of discussion today, IoT. I think everyone is carefully following and has been paying a lot of attention to IoT. This is the opportunity for everything and anything to connect. And, you know, we need to look carefully at the different type of use cases to understand, you know, what are the requirements on devices here. There are areas around the range, the power requirements, data rates, longevity and deployment life of the device, and all of these different examples of applications you see here have different requirements. So whether we're looking at healthcare, consumer, smart cities, agriculture, transport, they all have different requirements, and it's very important that we try and understand these differing requirements and importantly choose the right connectivity by the needs of the application. So very quickly here, just to set the scene in terms of short range and long range IoT. I think we're all familiar with the Wi-Fi routers that we have at home, some of the smart devices like the wireless speakers, fitness bands, and primarily all of these devices are using local area IoT connectivity technology. So whether it's Bluetooth, Wi-Fi, or 15.4 type of technologies, but they're all kind of local area with a limited range. We also have the wide area IoT technologies, and you can see some of the use cases here, whether it's agriculture, metering, bike share applications, or even forestry applications. So if you look at these examples, a local gateway, such as a Wi-Fi router, is either impractical or impossible to use. And this is why we have a delineation between local and wide area IoT. So the graph here is showing some of the various IoT technologies that are available. And on this chart, we're showing coverage in terms of distance on the bottom, and throughput in terms of data rate along the vertical axis. So on the left-hand side, you can see I've shown short-range technologies, and these are technologies that many of us are familiar with as consumers: Wi-Fi, Bluetooth, and also 15.4, sometimes referred to as Thread. On the right-hand side, we see the long-range technologies, so LTE Advanced, LTE-M, Narrowband IoT, LoRa, SigFox. So these technologies can enable many kilometers of range, but they also have different attributes in terms of whether they are using licensed or unlicensed spectrum. Licensed spectrum is what we're all familiar with in terms of cellular connectivity. So in terms of low power wide area, it's the 4 connectivity technologies on the bottom right that we're primarily talking about: LoRa, SigFox, Narrowband IoT, and LTE-M. If we talk a little about the requirements of low power wide area, basically what this technology is doing is connecting devices with very low bandwidth requirements. It enables battery power, so it's very low power technology, and you enable very long range and coverage. So you can see here things like deep indoor penetration, ability to connect many devices per single base station, and also drive towards a very low cost end product. So the kind of the key attributes here, differentiating versus the short range technologies. You're both cellular and non-cellular low power wide area technologies available. So I mentioned narrowband LTE-M earlier. In terms of non-cellular, SigFox and LoRa are the key technologies. So the slide here is showing what I refer to as a connectivity pyramid. So if you look in terms of the left-hand axis, as you move towards the pinnacle of the pyramid, you're enabling increasing device capability, increasing feature sets, but you also have higher device cost and higher device complexity. So LTE Advanced, 5G, LTE represent some of these technologies. As you move toward the base of the pyramid, you start to move towards the shorter range solutions or the lower cost technologies. So you can see here narrowband, SigFox, LoRa, LTE-M are highlighted. As you move towards the base of the pyramid, you're starting to look at a much broader deployment and higher volume of devices. A little bit about the market opportunity we see for low power wide area. So these are numbers from Machina Research from earlier this year. If you look at the top left chart, this is showing the total IoT device installed base. You can see as we go out to 2025, it's projecting about 28 billion devices as annual installed base. Now primarily a lot of this is short range technology, and this is Bluetooth, Bluetooth low energy, Wi-Fi, but there's also a significant proportion here in the middle band, which is low power wide area. So the chart on the top right expands out this LPWA opportunity. And you can see we've highlighted here the key component connectivities contributing to the volume shipments here. So narrowband, Cat-M, which is also LTE-M, LoRa and SigFox are shown. So if we look at 2025, the projections are suggesting that about 50% of the market will be narrowband IoT, and then you can see the rest of the volume being made up by these different technologies. We often get asked what kind of example applications low power wide area can enable, and we're showing here some very real actual use cases that are being deployed now. In this case, it's using narrowband IoT technology. So on the left here we have the bike share example, and this is hugely popular in China now. And actually we've also seen it coming to my hometown of Cambridge now. So we have Offo and Mobike, and they are connecting their bicycles to enable remote lock and unlock to enable use of the bicycle. Initially these bikes were using 2G, and now they're moving to narrowband IoT for the connectivity. In the middle we see an agricultural deployment example, and this is irrigation. So the Scandinavian carrier Telia has partnered with 7sense, and they're deploying irrigation schemes on farms, and this will allow real-time monitoring and control of the irrigation system. And then on the right-hand side, an example we have here of smart meters. So in Shanghai, the company Fiorentini is deploying smart meters that are using narrowband IoT as the connectivity technology. Smart parking is also another target use case, and there's been some recent trials actually in San Francisco that have shown that managed wireless smart parking systems can reduce congestion by up to 8%, reduce the miles taken to find a space by 30%, and also reduce the time taken to find a parking spot by up to 40%. So you can see there are actual very good beneficial use cases here to industry and society by deploying low power wide area connectivity. And just wrapping up here on the last slide, we have a vision as ARM about connecting 1 trillion devices. We were recently acquired last year by SoftBank, and this is an integral part of our chairman's vision. We believe ARM can be at the forefront of enabling this vision of 1 trillion devices, but we need to make sure we're doing this securely, and we need to have this security applied across the total value chain. It needs to be scalable from all the way down to low-cost devices, and it needs to ensure we can securely manage devices throughout their life cycle. So this is something that ARM as a company is particularly focused on to ensure we can meet our vision of 1 trillion connected devices.
Thanks, Chet, for taking the time, just explaining the basics of these technologies to us. So my first question to you would be on the concept of local networks versus the wide area networks that you mentioned. You explained that the radios used in the wide area networks have a longer range, but are there any other differences between these two, local versus wide area?
Sure. Perhaps we'll get a chance to talk about some of the technical differences later, but I guess let's use the smart gas meter that I showed as an example to illustrate one of the biggest differences between short-range and long-range technologies, and that's ease of use and in-life management. So, you know, a utility provider could install a smart meter, say with a Wi-Fi connection, but this necessitates the homeowner to have an internet connection, a Wi-Fi router. They need to make sure the Wi-Fi connection is always up and running, the broadband connection is always live, and that the user can configure the meter to connect to their local connection. So if I look at the case of, say, my mum as an example, she's not really going to be able to cope with this kind of complexity, and ultimately she'll just end up calling the utility company and asking someone to come home to configure the connectivity. So suddenly this smart meter becomes a dumb meter, and the utility provider needs a man in a van in terms of a truck roll, which is going to add OPEX, and this is going to negate the whole point of having a smart meter in the first place. So alternatively, the utility provider could have installed a smart meter using a cellular IoT connection. I mentioned LTE-M or narrowband IoT. And because cellular devices operate in this kind of managed spectrum, out of the box they're going to configure and connect to the cellular network as determined by the SIM function. So, you know, the benefits of managed spectrum mean that the cellular carrier and not the utility provider is going to ensure the quality and availability of the connection. The other key point probably here is that the wide area networks are able to support many tens of thousands of devices per gateway or base station, and short-range technologies are usually limited to tens or hundreds of devices per gateway.
Understood, Chet. Thanks for that. So, I mean, if these smart meters take off, will I end up with 20 mobile bills each month? One for my phone, one for my smart meter, one for my washing machine, one for my smart camera. I mean, I think I can barely afford what I can pay at the moment. So how does that change what we pay out to the telecom companies as such?
Yeah, good question. I guess broadly the answer is no, but it will be a little bit a function of the use case and the business model for whoever's providing the service. I think in the case of Wi-Fi, Bluetooth connected devices, typically the router or your smartphone is the gateway connecting that device to the internet. So there shouldn't be any additional billing for those kind of devices. But I think you mentioned washing machine and white goods. The network fees will have been agreed by the washing machine OEM with the carrier in advance. So these connection fees will already be included in the price of the product, and the user is not going to be billed directly. We're seeing this approach already being used with some connected cars, around things like eCall. But I guess a really good example is Amazon's Kindle, which, when you buy the Kindle, you have cellular connectivity built in, and it lasts the lifetime of the device. So I think that's a good example of how the user's not actually paying for built-in connectivity. Also bear in mind, what we're talking about here in terms of low power, wide area devices, that they're not going to be using very much data at all. So the carrier will only need to charge, say, a couple of dollars a year, but this is incremental revenue, and they're not really burdening the network in terms of their core revenue streams.
Understood, Chet. So what it means is that we will not be getting 15 more bills in the future. What it would be is that the price of the connection is possibly included in the price of the device, which makes it much easier for a consumer as such. Will this the same way be used in the same way in the industrial market as well?
Yes, I think this concept will apply broadly to where we see these low power wide area technologies being deployed. If we try and make this too complicated, then we're just not going to see widespread adoption. So it's critical. Ease of use, ease of business model, ease of business billing is built into these technology deployments.
But at the same time, what you're saying is that the telecom operators will get remunerated for the use of the networks, because one of the issues they've been having, as you know, in recent years, is they've not seen their ARPUs go up, but this could be actually additive to their revenues as such.
Absolutely, but it's a volume play. I think they can't use the approach they've used for smartphones, $10, $20, $30 per month tariffs just aren't going to apply for this. The whole point of IoT is to have massive deployment, billions of devices, and the carrier is making revenue by connecting these billions of devices.
Understood. Thanks. My next question is, which of these technologies you've talked about are the key low power WAN technologies?
Okay, so I guess probably up front we should say that ARM is agnostic to the specific connectivity that's being used, and actually our IP, our technology, is being used in all of these systems. But probably the way to look at this is there's two deployment modes we need to consider here. There's enterprise-led or telco carrier-led. Maybe if I can use a mining company as an example, they might choose to deploy their own private low power wide area network using LoRa, for example. And in this case, it's great. They have full control of their deployment and its rollout, but they're also taking on the responsibility for installation, for maintenance, and for running that private network. And for their business objectives, they may decide this is okay, this is mission critical. The other example I could give perhaps is a municipal corporation or council might want to deploy smart street lighting, but they don't really want to run their own network and don't really want to have that responsibility. So they will tend to want to rely on the telco's cellular infrastructure and let the carrier have that network ownership. So, both of these models are valid, but the choice of connectivity is actually a byproduct of the end business needs of the user.
Understood. Based on current indications that you see, you mentioned earlier in one of your slides that that one of the technologies would be the dominant one. But is that what you think, that based on what that market researcher is saying, that NB-IOT will be the dominant technology, or maybe you can differentiate between some of these technologies and how these will be deployed, and in terms of market share by 2025 as you're talking about?
Yeah, I guess there's a few points to come out there. I mean, firstly, it's still very much a nascent market here for IoT. We're in the early days, and we're seeing, cellular deployments, non-cellular deployments already happening. So LoRa, SigFox have enjoyed early deployments just because the technology has been available earlier. We see the carriers now are starting to adopt and deploy LTE-M, narrowband IoT. They did have to make some upgrades to their infrastructure, and that's caused somewhat of a delay. The standards have been catching up. But if you look at the industry body that represents carriers globally, the GSMA, they now have dozens of carriers globally committed to deploying cellular low power wide area technology. So, in terms of which technologies are going to become prevalent, there's also today there's an element of geography coming into it. Narrowband IoT's got a great footprint across Europe and China. LTE-M is being deployed in the US, and just specifically on those examples, in China earlier this year, the Chinese government, the Ministry of Information and Information Technology, made a policy declaration that by 2020 every LTE base station in China will be narrowband enabled. And actually, by the end of this year, they're targeting almost 500,000 base stations. If you look here in Europe, Vodafone, Deutsche Telekom have already launched live networks around narrowband IoT. So, we're seeing kind of a parallel deployments of different technologies, but actually, probably what's going to be key to the success of any connectivity standard is that the technology it's based on is an open standard. So we've seen historically open standards receive the widest industry adoption, and that's because you get global interoperability, it encourages innovation, it's leading to economy of scales, and that brings down costs. So, I think we will see many of these technologies coexisting, but probably the open standards are the technologies that will probably get the largest foothold.
I mean, we saw in the cellular market, that until GSM came along and standardized it, globally GSM became the standard. But then we needed the devices were moving between continents, etc., which meant that we needed this standardization. Is standardization lack of standardization, going to impede adoption of the IoT market? Because I don't at the moment. Maybe you can help me on this. Are there use cases for devices which need to talk to each other, for instance?
Yeah, well, I think yes, lack of standardization will impede deployment. I think primarily what we're talking about here is how do we connect a device ultimately to the internet. We're talking less here about devices connecting to each other. Perhaps that's more like a mesh kind of setup. I think devices connecting to the cloud is where we see opportunities for service provision and new service revenues. So I think probably that's the major use case here of device to cloud and cloud to device, as opposed to device to device.
So that would indicate to me that the lack of standardization doesn't impede market development as much, because each one of these separate technologies would all automatically have device to cloud and cloud to device as such, really.
I guess if you have a proprietary standard, then you won't necessarily get the weight of the industry all coming behind it, because when you have proprietary technologies, you can't leverage the economy of scale of dozens of silicon vendors, multiple infrastructure vendors all coming behind and developing technology that can interoperate and deliver that standard. So I think, yes, that people can develop proprietary technologies, but then if you ultimately want it to be low cost, and if you want devices to talk to the network, then you do need standardization.
Understood. Thank you very much, Chet. I mean, moving on from there, a telecoms operator recently told me that the Internet's OSI stack needs to be redefined for IoT. Standards such as TCPIP and HTML have too much data overhead for these small devices with low bandwidth. Do you agree? And have these new communication standards such as HTML or TCP been redefined for the IoT world?
Yes, I do agree. Everything we're talking about here is to enable large-scale deployments, and that necessitates low cost, and having a very heavyweight protocol basically puts unnecessary burden in terms of processing requirement, in terms of memory, and ultimately the cost goes up. So we have seen transport protocols such as CoAP, Constrained Application Protocol, and MQTT coming out, in the industry adopting these so that we're not unnecessarily overburdening requirements on these end devices. So yes, I would tend to agree that the industry's seen this issue, and we are seeing solutions being brought to market to try and address it.
Now, in terms of the different standards, the radio interfaces we just talked about earlier, I mean, there are so many different protocols that you've mentioned and very helpfully in your presentation. It's very difficult for us analysts to follow every one of them. Clearly, I mean, it's not yet like the GSM world as such, where 3GPP defined the way it went, and maybe that's the way it's going to go in the future in IoT as well with NB-IOT, etc. How do you feel about the OEMs today about designing with these multiple standards? Are they confused about which ones to adopt when designing a product, or are they gravitating in one way or the other?
Forget the OEMs. I'm confused, Sandeep. This is, as an industry, we haven't done a very good job of explaining, what are the trade-offs here in terms of different technology? What will they enable in terms of, ultimately what really matters is what is the business problem you're helping the OEM to solve? So, I think we refer to IoT as a single segment, but actually it's thousands of verticals with differing needs, different attributes. You mentioned GSM. The smartphone world was much simpler because the industry coalesced around one form factor, one standards body, and that defined 3G, LTE, and now 5G. So the complexity was relatively contained, and we're not quite there with IoT. We are starting to see some convergence and alignment around the industry, standards bodies, consortia, technologies. We're seeing mergers of different standards bodies, but it's not going to be, unfortunately, quite as simple as smartphones, and we need to do a better job as an industry educating people, move people away from talking about technology. And some of the people we're talking about who want to benefit from IoT, they're, agriculture, for example. The players in agriculture don't really understand wireless. They don't understand electronic subsystems. So what we need to do is not talk about the nitty-gritty technology and talk more about how we can provide solutions to solving their business.
Understood. Maybe I can go to one of the things you mentioned. I mean, what is this hampering? I mean, clearly IoT has been mentioned as a major driver for the semiconductor and tech industry over the next decade. I mean, clearly, one of your chairman has talked about the reason he acquired ARM was for the IoT market in the long term. So, I mean, what is hampering today the takeoff of IoT? Is it standardization? Is it cost? Or there are other issues? Because we've seen the cloud take off now, but IoT has been talked about at the same time as the cloud has been talked about. The cloud clearly has taken off, and we can see that impact on the tech industry.
Yeah, well, there's multiple factors, really. I think cost for sure is a challenge today. But generally, electronics industry's got a good track record of driving down costs of subsystems, and this is where the point about open global standards is critical, because you enable the widespread participation of different stakeholders, and you get to a point of driving economy of scale. Power consumption actually has been, a limiter today of where we can deploy some of this low power wide area technology. You mentioned 2G. 2G actually was quite a good technology for IoT, but it didn't support battery power very well. And some of the new protocols that have been written, some of the new technologies have been written with low power consumption in mind. So if you look at narrowband IoT or LTE-M, they've kind of been written to be mostly off. So there's a very low duty cycle, and that means they're only sipping the battery power, very conservatively. So if we can move the industry to the point where power becomes, doesn't become a problem, it's going to start enabling a whole new bunch of use cases. I guess probably last but not least, security has been one of the biggest barriers to the deployment and adoption of IoT. If you look over the last couple of years, there have been quite a few high-profile news stories around cars being hacked or corporate databases being infiltrated. We saw the huge distributed denial of service attacks. Basically consumers, enterprises are totally losing trust in this kind of new connected world and IoT. So I think we need to make sure that security is being built in from the ground up and is not an afterthought. From my own personal experience, some electronics and semiconductor vendors, believe they shouldn't consider security because it adds costs. And I think what they need to realize is the cost is, the real cost is of not doing building and security from the ground up, because they'll lose business, they'll lose corporate trust, and in some cases, unfortunately, there's going to be a risk to human life as well. So, a couple of weeks ago, our CEO, Simon Segars, spoke very extensively about the critical importance of IoT security, and his assertion is that we need to collectively, as an industry, take responsibility and commit to making sure security is baked in from the ground up. We need to do this as an industry. Simon also announced a security manifesto, kind of a call to arms to the industry to, let's work on this together, because this is going to really impede the future deployment of IoT.
Understood, Chet. Thanks for that. One of the points you made was on cost. And on cost, you said the industry has been good at bringing down costs, and that's true as long as Moore's law continues to work. But what is the optimal unit cost? And because there are two costs here, right? So there's the unit cost and there's the subscription cost. And are they impacting adoption? And what is the optimal unit cost that needs to be achieved? Is it $10, sub $5, or sub $2, or is it even lower than that to make the the so-called trillion unit market happen that you mentioned?
Yeah, I guess the glib comment is zero, but as low cost as possible. And I think we've got a good example we can point to. If you look at 2G GPRS modules, they're available for about $3.50 today. So this is kind of showing the industry the trajectory we need to go on to enable this mass adoption. If you look at LoRa SigFox modules today, they're in the range of $2, $3, $4. I think narrowband IoT needs to get on a trajectory to be sub $5 and really heading towards this $3.50 that I mentioned for 2G modules. So that's the device cost, and I think you've rightly pointed out, actually there's also the cost of the subscription of enabling the data. And I think here different carriers are taking different approaches. I think some are trying to use the same approach that they have for smartphones, and I think ultimately that's going to fail. If you're going to try and charge $2, $3, $4 per month per device for connectivity, really that will hinder the uptake and success of IoT. I think carriers need to be a little bit more visionary here and say, look, we'll enable the connectivity for a fixed cost, and we'll give you all the data that's needed for the lifetime of the device. And I think this is where we'll see the adoption of IoT really taking off.
Understood. Now, clearly, I mean, within the cellular space, there are two contenders, right, at this point, which is NB-IOT and LTE-M. Is this a decision on NB-IOT versus LTE-M decided by the operators, or is it decided by specification that that LTE is only going to be for supporting LTE-M, and then NB-IOT is on 5G or whatever? I'm not familiar with where these decisions get made.
Yeah. Again, good question. If you remember back to the connectivity pyramid that I showed, LTE-M, narrowband IoT are kind of sitting, in different places. They're enabling different use cases. So LTE-M is much more like a a cut down LTE technology, and it's very good at enabling applications needing mobility, like real-time asset tracking or voice, such as alarm panels that are voice enabled. Whereas narrowband IoT is much more suited to kind of static, simple sensor type, actuator type applications. So I think that the choice really will be determined by what is the use case that you want to enable. So it's not really a question of narrowband or LTE-M, it's what do you need for your application. And what we've seen with carriers now, whereas they initially were aligning to deploying one technology or another, and we kind of had this fake news of the big war between LTE-M and narrowband IoT, carriers have now realized actually to capture the broadest range of service provision, they need to deploy both of those technologies.
Understood. Thanks, Chet. I mean, the last question I would ask you would be, clearly, ARM is highly involved in this. ARM is by far the microcontroller leader in the IoT market. And what is ARM doing to engender the IoT market from happening in terms of the protocols and standards, in terms of the ecosystem, as well as, the chip design to market, such that your customers come to market quickly with the chips, and thus IoT devices are available more quickly, and then whether there are any other enablers that ARM is working on as such.
Okay, yeah, good question. And as we mentioned earlier, one of the key reasons that SoftBank acquired ARM was because of the vision of IoT that we can help to deliver. So if you look at it, there's multiple things that ARM's doing here. We're obviously focused very much on the processor technology. Our Cortex-M family has been developed to enable a very rich feature set for microcontroller-based IoT applications. But again, battery power is critical here, and we've employed a lot of architectural techniques to ensure the processors are suited to very low power, low cost devices. In terms of ecosystem, it's been a long-term focus of ARM, and we have the Mbed platform that's enabling the OS on devices, but we also have its sister cloud services platform as well. We're working very closely with various independent software vendors to make sure that they can very simply adopt our IP and tools and help enable the market. We have a program called Design Start, which is simplifying access to ARM's IP, to software, to tools, and this is really targeting the long tail of developers in the industry. And then we spoke a lot about security. A couple of weeks ago at our TechCon event, we announced something called platform security architecture. And really what we're trying to do here is align the industry around common security principles. And we're providing enablers to our partners in terms of hardware and software to design, develop, and deploy secure endpoints cheaply. So, and now here I am in my new role at ARM in the IoT device division, and I'm responsible for ensuring that ARM is bringing together the key IP components, whether it's processor, radio, security, system IP, to simplify the route to market for our partners. But a key part of my team's role is also to engage with the wider ecosystem. So I mentioned cloud players before, device OEMs, software and EDA partners, standards bodies, potentially even regulators, to ensure that we're collectively working together to make IoT a commercial reality for the industry. So, yeah, pretty confident that ARM's well placed to both enable and participate in the success of IoT.
Thank you so much for taking the time to talk to us and educate us on this emerging market yet, because I don't think the investor base understands, this alphabet soup in terms of the different technologies, but we at least now will understand which way the market is going and the kinds of technologies that are being developed, as well as, the way the subscriptions and the unit device costs, etc., work to make so that we can determine when we think that the market will begin to take off, which is very critical in the investment process. Thank you so much, Phil, as well, for organizing this. So I'll hand it over to you, Chet, if you want to make any last comments.
No, thank you so much for the opportunity, Sandeep. Really appreciate it.
Yeah, thanks very much, Sandeep, and thanks, Chet. And thanks everyone who's joined us today. Just as a reminder, if you're interested in IoT technology, you can find plenty more content for investors on www.arm.com/IR.